Saxon's Trig, lesson 77, is about binomial expansions, and it's the first time we've talked about them. They begin with showing you a chart of what a pattern looks like when I take a plus b to the 0 power, and anything to the 0 power is just a 1. What happens if I take the a plus b to the first power? Well, that's just a plus b. So they're showing you that you have an a and a b with some 1s here. They are writing it with the plus sign, but I'm going to explain why I'm not here in a second. The next one would be a plus b squared, and that would be a foiled out. So the first one part, I know I would have an a squared. For the middle term, I would have 2 ab's, and for the last part, I would have a b squared. And then I'm going to stop it after this layer. I would have to then work out this distributed with another a plus b. And what I discover when I finish that is I have a 1a cubed. Oh, I put the plus because they had it. A 3a squared b. Another 3a squared. No, ab squared. I knew that didn't sound right. ab squared. And ending with a 1b cubed. All right, so then if I did another one with a 4, I would get a much longer line. All right, so what happened was mathematicians did this long work multiple times, and they were getting these answers, and when they were lining them up on the paper like this, they discovered a pattern. Now, the mathematician that discovered the pattern was Pascal. So he gets credited with calling it Pascal's triangle. There are some arguments that other mathematicians came up with it. There always are arguments between mathematicians as to who came up with what. But Pascal is the one who got credited with it in history, so that's what we're going to call it, Pascal's triangle. So what he determined was when we have 0 as the exponent, 1, 2, 3, 4, I might take the pattern up to 5. I will recommend that in your notes, you carry this pattern down to 10. Keep it there as a reference to use. All right, but the start of anything to the 0 is a 1, and then 1 gave you, and what I'm doing is I'm pulling the coefficients, I'm ignoring the letters, the coefficients only. And so in this one, I know it was 1, 2, and 1. Well, what he discovered was this middle piece is always the sum of the 2 above it. So 0 always gives a 1, 1 and 1 always gives a 2 for the middle, and the beginning and the end always have 1s. So for 3, this is 1, 1 plus 2 is 3, 2 plus 1 is 3, and then I have my 1 at the end. Okay, so for 4, I know I'm going to have my 1s at the end. 1 plus 3 is 4, 3 plus 3 is 6, 3 and 1 is 4, and obviously that will always be the same. And then for 5, 1, 5, 10, 5, sorry. 10, 5, and 1. There we go. So like I said, I recommend that you keep going and finish the chart up to about 10. You should never need to reference higher than a 10. If they would ask that in a homework problem and I've just forgotten, just expand your thing. Okay. But now that you understand that the coefficients of these are written here in a shortcut form for Pascal's triangle, we can easily, without having to multiply out and distribute and combine like terms umpteen times with these, we can use this to shortcut to very quickly get the coefficients. How beautiful. And now I'm going to show you how you can get the, whether it's cubed, squared, fourthed, whatever it is, very quickly. Okay, so for let's say the 4th. I didn't put it up. No, let's do the 3rd so you can see it here. Okay, so for the 3rd, I know that my coefficients would be 1, 3, 3, and 1. All right, so 1, 3, 3, and 1. So you've proved that there. Okay, so then you would just do a very quick little, and I like to do it sideways, X and Y chart. So the first one goes from highest down to lowest. So if my exponent was 3, it's going to go 3, 2, 1, 0. For my y, it's going to go the opposite, 0, 1, 2, 3. So this tells me that I have, now I used x, y, these were a, b's. let's change this to AB so it's not confusing. I want you to see how it actually works. A, okay. So here I had 1A cubed and no B. Beautiful. My coefficient was 3. Yep. A squared, B1. A squared, B1. Perfect. Next coefficient, 3. Great. And then it was A1, B2. A1, B2. You see how the pattern is working. So with Pascal's triangle and a very quick reference point here, so the last one is of course coefficient of 1, yep, and then no A and B3, yes, that is what I had. So using these two things, I can very easily distribute out without doing all the distribute to get to an answer. So example 1, write the fourth term of x plus y to the sixth. Okay, well, unfortunately, I did not give you the 6. So we'd have to do that real fast. 1, 6, 15, 20, 15, 6, and the 1. Okay, so the fourth one over, 1, 2, 3, 4. So I know that I'm going to have 20 as my coefficient. And then because it said x's and y's, I'll do my x's and y's. So this one goes from I had exponent of 6. So it goes down 6, 5, 4, 3, 2, 1, 0. This one climbs 0, 1, 2, 3, 4, 5, and 6. It wants the fourth one over 1, 2, 3, 4. Okay, so that is x cubed, y cubed, and that is the answer to the fourth term with the exponent of 6. A whole lot faster than trying to distribute out that many times and combine like terms. Example 2, write all 8 terms of the expansion x plus y to the 7th power. Okay, so again, I don't have the 7th one. That's why I said you need to have the list up to 10, but knowing that my first is always an A, I know that this chart is going to be 7 down to 0 and 0 up to 7. So my first one is x to the 7th. I'll just pretend I've got the extra layer there. Okay, first term plus, so then that would be 1 plus the 6 is 7, and then I would have x to the 6th y plus 15 and 6, 21, x to the 5th y squared plus 35, I'm going to have to write it down here, 35 x to the, going down 4 y cubed plus, and now I'm repeating these again, 21 x 3 y 4, and then 7 x squared y to the 5th plus my 1. Why do I feel like I missed one? Did I had to have. 1 and 6 was the 7, 21, 35. Oh, good grief, I did it again. This should be 35, yikes. Then 21, now 7. Okay, that's making a little more sense. X, y to the 6th, making sure you can see that, plus, and then my last one is the 1 with no x and y to the 7th. And there is the answer fairly quickly using Pascal's triangle and the chart.